Got a new portable power station by Bluetti. This one's the EB3A. And this one features a lithium iron phosphate battery, which is a lot safer than your standard lithium ion batteries. We're going to take this one apart, take a look at it, and give it a little test run and show you guys what it looks like inside. We're going to open it up and do a teardown on this one and do some testing, see what it's all about. I haven't even opened this one yet, so I have no idea what to expect. This one's in steel gray. This one's the model EB3A portable power station. This is a new model that has just launched over the last little bit. We'll go over the specifications and then we'll run some tests on this unit, and then I'm going to take it apart. It's got built-in wireless charging. Here's the unit itself. You're wondering where the AC cord is. It's under the unit in the box. I was scratching my head wondering, where is the AC power cord? Just uses a standard computer cord as well. Also an optional, and they sent me this cord for charging this up from a solar panel. So we'll do that. I have a solar panel, 100 watt. I think it's 100 watt. Anyway, I got a little solar panel. We'll plug this in and charge it up with the solar panel. It's a different brand of solar panel, so I won't show that, but we'll plug it in. On the front, you've got your AC charge, DC charge. That's where this one would plug in, to plug into a solar panel. You can also charge it from your car battery, etc. Its input is 12 to 28 volts DC at up to 8.5 amps. So that will charge from your solar panel or from your car. And of course, AC charging. To charge it up on AC, just simply plug it in and it should light up. So right now it's at 64%. And it will start to, once it starts to charge, it's charging at 259 watts. Now, something I've always been curious on a lot of these units is, can it charge and output power at the same time? Well, let's find out. Let me just plug something in here. Now, this one has a 600 watt output. So I'm going to try plugging in my heat gun in low power mode. I want to see whether it'll let me draw power from the unit while it's charging and operate as a UPS, because that's what I find that really useful, the ones that can do that. So, aha, when I turn this on, is it going to kick in, or is it just going to run? It might be because I'm drawing too much power. But it's not, the input is not going right now. So what I'm curious as to whether it can operate a device while it's charging, which it's drawing 260 watts now. Obviously when I plug this in, it's only supplying 346 watts. Now this is rated at 600 watts, but that is more than likely a surge. And that might be why it's shut down the charger while it's doing, while it was drawing power. So let's power something up that's a little bit more conservative and is not going to draw the maximum amount of power that this unit is capable of operating with. Let's plug in my stereo. My stereo is only going to draw 38 watts. Okay, now it's able to charge, and it's telling me that the battery is charging. If we look at the indicator here, the battery is charging. Now if I remove power, now it's continuing to supply power. So this unit will operate as a UPS. Excellent! exactly what a lot of people will want. You want a battery backup that you can power your computer from, but you can have it plugged in so that it's running off AC, but your computer is still battery backed up. In this case, it will operate as a full uninterruptible power source. I like it. Already, even without taking it apart, I like it. That's a feature that I think most people will find useful. You can still take it camping with you for sure, but having that battery backup to power your computer in the event of a power failure, because if your power goes off on your computer while you're using it, you're going to, you could lose data if your hard drive is being written to, for example. So UPSs are important to have, and this one here does that quite nicely because, oops, I hit the power button. Dope! I killed the power. It can operate in UPS mode, and it'll light up here and say that it's in UPS as soon as it kicks in. There you go. Now it's in UPS mode. The battery is charging. Once the battery gets to a full charge, I would imagine that the input power will equal the output power once it gets to a full charge. Unplug the power. Goes into UPS mode. Power stays on. Okay, so now we know that it does operate as a UPS, which is good. Of course, it'll operate as also as just a power inverter. Obviously, you can turn it on and off with the power button here. Right, power on, it tells you your AC is on. You can plug your devices in. It has 2 USB-A ports at 3 amps each, and it also has a USB-C port at up to 100 watts, so you can charge up USB-C devices. And it has the wireless charging on top, so if I put my phone on top of it, do I have to turn anything on, or will it automatically detect that my phone is there? Let's see. I may have to turn it on. I may have to turn the DC output. I probably have to turn it on. Whoops. Yeah. It might help if I plug the power cord in properly. If I turn on the DC output, there we go. That should turn on all the DC output, both the standard cigarette plug size as well as the other output. So if I set my phone on top here, my phone should automatically go into charge, which it does. So there you go. Another bonus. You can charge your wireless devices as well as your USB devices. It has 2 10 amp outputs here as well as this DC output, and there's a light. So when the power is out, you've got a flashlight basically. And has the 3 modes, low, high, and SOS. All right, let's take this thing apart and see how well it's built. So if we look at the specs, the cells that this one contains, lithium iron phosphate batteries, and they're an expensive battery type because they're a relatively new one, but they're also considered to be the safest of the lithium batteries. So if we look at the specifications, it has an AC output of 600 watts with a surge of up to 1200 and 5 amps on the 120 volt version. The DC output, you can have up to 10 amps output for the 3 standard DC ports, and your USB is 5 volts at 3 amps or 100 watts on the USB-C, and up to 15 watts for wireless charging. The AC charger has a 280 or 268 watt charger, which can draw up to 9 amps on the input, and DC input up to 200 watts maximum from a solar panel or from another battery. 8.5 amps. So when it's in UPS, when it's charging, the UPS light is on. While it's charging, if you turn on the AC power, it will turn on the output power. It's not running the inverter, so it's in bypass mode, so the AC power is going to be passed directly to the output. and only if the AC power goes off will it switch over. So probably hear it click here when it does it. Okay, UPS is on now, I think. Yeah, UPS is on and AC is on. When I unplug this, we'll probably hear a click as it switches over. There, it just clicked. So now the inverter is on. But the important thing is it will operate as a UPS, whereas some of them that I've tested will not. As soon as it's connected to AC power, it shuts off the AC outlets. And you can also, if you're charging it with your solar panel, you can also run the AC inverter at the same time. So it can charge and discharge at the same time. Obviously, if your AC power is going to draw more, or your AC device is going to draw more power than your solar panel is outputting, then it's going to discharge the battery if you're running full power. But if you're running a light load, then it's possible to put charge in at the same time as you are operating your AC device. Let's get into this and see what's inside. I would imagine that the screws are probably hidden under the feet, so we'll just pop the rubber caps off, and sure enough the screws are hidden below, which is usually a trick that they do. I would expect that this unit is going to somehow pop apart. Looks like the top comes off just like that. Excellent. Let's just unplug. Oh, they've got everything glued down. So we'll remove the wireless charger first. Or just let it hang over the side there. This is the inverter board. And this is going to be, I think the battery is probably plugged in down here. I'm just looking for where the batteries are on this unit. This is the battery pack down below. We'll unplug the, this is going to be the battery here, so we'll unplug the battery that way. Okay, now the unit is safe. Let's check the battery voltage. I think it's like 22 volts, but we should see the battery voltage on here. .27 volts, fully charged. So this is the battery is, yeah, this is the battery pack. We can see all the cells. If I remove the inverter board here, looks like it's also connected to here, so we'll just undo that plug as well, and I'll just clip that that zip tie that's on here. And I can unplug this plug from that board, and we'll just remove the inverter. I think the inverter is just held in place by a few screws, so we'll remove the inverter board as well. There's another plug over here that has to come out. Okay, this should be disconnected now. Push this clip in. There, okay. Now the inverter should be completely disconnected from the battery, and we can safely remove the screws. To take a look under the main inverter board. I always get nervous when working on UPSs because, of course, that battery is charged, so you gotta really kind of watch yourself that you don't short anything out when anything is connected, or you could have yourself a bit of a problem. And if lithium batteries were to go up, you're not stopping them, put it that way. So extreme caution really needs to be taken whenever you're working around any of these UPSs or battery backups. this lift off. There we go. Now this lifts out. Unplug the fan. And there is the inverter board. Take a look at the quality of that in a minute. We'll set that aside for now. 4 more screws to lift out the battery itself. These are relatively long bolts that go into the base. This plate, or is it the whole battery that lifts out? This is the plate that comes out with the fan and everything on it. Will lift out. The whole front will lift off. There we go. Okay, now you see the cells that are in this unit, and the front plate just lifts off just like that as well. So now we can appreciate the battery pack that's in this unit for what it is. It will probably lift out, maybe not, but what do we have on here? 10, 14 cells. And that's the battery pack. I'm not going to tear it down any more than this. This is the battery protection circuit over here. The battery terminals are soldered on there and there, but that's the battery protection and charging circuit. And I'd say I'm not going to remove any more. Actually, it looks like it's connected in more than one place. It's connected here, 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 and there's looks to be 4 more connections on the bottom. But that's the limit as far as I'm going to go as far as taking the battery itself out, because I think it's probably stuck down with sticky tape on the bottom. I would imagine it's stuck down just so that it doesn't move, so I don't want to disturb that, but you guys get the idea. There's the battery. This is the control board. We'll look at the control board next. I'll just move the battery out of the way while we look at the other boards, and then I can put this unit back together. There's the battery. Here's the control board with the wireless charger. As you can see, all the critical parts are glued in place. All the capacitors and coils and stuff have been glued down with, it feels like silicone. This is the AC output, which plugs into the inverter board. The DC output is here. Everything's got a rubber boot on it to protect it. All the connections that could be considered hazardous. This is the AC charge, for example. They've all got boots on them, as well as there's a circuit breaker here. This is on the main input. You'll see the AC power. Neutral goes straight through, but the AC power goes through a 10 amp resettable circuit breaker on the front, which is this one right there. All looks to be very good quality construction. Looking at the board, it looks beautiful. It's all got a conformal coating on it to keep out moisture if you're using it camping, for example. We'll get a look at the actual inverter board next. I'll just set this one aside. So this is where the AC plugs in. AC plugs in right here. This is the AC output. If you look on the bottom of the board, here's the inverter. Again, it's got a conformal coating on all the transistors, all the MOSFETs. Transformers over here. It's going to be a DC to DC converter type inverter, so it's going to take the battery power, convert it over to a high frequency, probably 40 or 50 kilohertz, run it through the transformer to step up the voltage, and then there'll be a sine wave power inverter that then converts that high voltage DC over to a 120 volt AC output. So these transistors on this side, or these MOSFETs, these will be the ones on the primary side that convert the DC from a DC to a high frequency pulsed DC signal that goes to the transformer, and then on the other side over here there'll be a diode rectifier to rectify it from AC to DC. Looks like that's probably these ones here. and then there'll be other transistors, MOSFETs, that will then convert the rectified high voltage DC back to a sine wave AC and pass that through to the output over here. It's marked grid, line, and neutral, and load, neutral, and line. There are temperature sensors on the heat sinks right here, both of them. That would control the fan to turn the fan on to draw the air out and cool it down if it's heating up. Again, construction wise, it looks excellent. Everything is glued down for vibration protection when you're traveling around. If you're carrying this around in your camper or your car, it's getting banged around. You don't have to worry about parts breaking loose just from vibration. Everything is glued down or it's screwed down, one of the two. So that looks good. I think it's time to start putting this unit back together, and then I'll hollow out my solar charger. We'll put it on the solar charger and see how the solar how it charges up. So first, I'll drop the battery bracket back in place and put the screws in place. Pop that piece back in place. And then the inverter board slides back in. Fan's got to get plugged back in down here. Probably one of the most important plugs there is for the fan. If the fan goes out, everything's going to go out. Next, I'll start reinserting the power cords. They are keyed so that they only go in one way. You can't mistake them. And plugs in there, and then that one there, and then there's another one that goes down here to connect the front board to the main board. Then the last two that get plugged in are the battery. So I'll plug in this one first. And then finally the main battery connector plugs in there. And now the unit should be ready to power up again. If I turn it around, I should be able to power it up even without putting the top on it. But now, as I say, it's at that point where there could be hazardous voltages generated on this inverter. I want to make sure that it works before I put it all together. So power on, and yes, it's lighting up and it's turned on. Turn it back off, and now finally just to put the top cover on. And say it goes together real easy, just like that. Alright, I'm just going to get the bottom on it, and then I'll take the solar panel out. We'll plug it into the solar panel and I'll let it charge up, and I'll actually complete the charge cycle on solar, and we'll see how long it takes to charge. It just so happened to have a solar panel from another company, which I won't show because you can use any of them that support 12 to 18 volts. I think it's 12 to 18. Yeah, no, 12 to 28 volts. So we just match the connectors because this part is all universal. We just plug the two connectors together. I'm going to take the unit outside, sit it in the sun, and we're going to plug this in, and I'll pick this up outside with the other camera. So I'm outside now. It's a sunny day. It's kind of overcast. It's not direct sun, but it's pretty bright. Let's see how much power this solar panel is generating. It's rated at 100 watts, so let's see how much power we're actually generating. Right now, under an overcast sky, I'm generating 59 watts. A few minutes ago I was up at 95. As the clouds are starting to part a bit. So at this rate, it's going to take 1 hour to fully charge this battery. It's at 77% now. And as I say, the power is going to fluctuate because, well, there are clouds up there. As you can see, there's high clouds, so this is filtered sunlight. So solar panels don't put out maximum power unless you've got full open sky, and that's not happening that's at this moment anyway. So I'm powering a television. It's getting more overcast now. I'm getting only 26 watts from the solar panel, and the television's drawing about 89. As you can see, the time to full charge the battery is increasing because the output from the solar panel is falling due to the losing the light, but it is powering the television basically from solar panel. If I was under full sun, I should be able to get enough power to completely power this little, well, 30 odd, over 30 years. This goes back to the late 80s, 88 or 87. Little CRT set that sits outside on my patio year round. Like, this has not been brought in since the last time I had to fix it. It's left out here year round. As you can see, the clouds are getting a little heavier. I'll go have my lunch and pick this up after lunch and see whether the clouds have parted. Unfortunately, the sun never came back. It actually got cloudier, so the power has dropped off. Up to 89% now, only 16 watts. And it's still going to take 2 hours, providing we don't draw anything from the output while it's charging. At this light level, it's now overcast. Anyway, that's a quick look at the Bluetti EB3A 600 watt, 268 watt hour portable power station. Great for emergency backup. Great to use as a UPS, so you can keep your computer running during power failures. And it's got all of your DC outputs that you could ever want if you're camping or even on a road trip, just to keep with you so that you can keep your devices charged. Also neglected to mention that you can also control this from an app. You can download the Bluetti app from Google Play or the App Store, and then control the unit itself from your phone. So once I've installed the app, I just have to connect it to my device here. So let's just see if I go to connect. And please turn on Bluetooth. Yes, it's on. And I'll just let it find the device. I have not had to create an account or anything. I just turned on the app, and it should find this thing. Oh, I guess that's the one there. It's at the tap it. There we go. Successfully connected by Bluetooth. So you don't have to, and now you don't have to create an account or anything. Just download the app, and now it'll communicate over Bluetooth, and it tells me that DC power is on. I can turn it off, right? When I turn it off on here, I can control it remotely. If I want to turn the AC power on, I can just tap on here, and we're AC down here. I tap the AC power on. I just turned it on remotely. Right, if I want to turn on the DC power, just tap down here, and it will turn on the DC power. It's telling me right now that I'm connected by Bluetooth. I've got no power coming in from solar panels because they're not plugged in, but if there was a solar panel plugged in, it would tell me how many watts I'm charging up. I'm drawing 144 watts from the grid to charge up, and I'm not using any AC or DC at the moment. And it's letting me know that it is charging, and once it reaches 100%, it will stop. Now, if I tap the settings button up here on the screen, I can now go into different modes, like eco setting. So eco setting will turn it off if it's not detecting a load for 4 hours. I can change that from 1 hour up to 4 hours, or I can turn it right off completely, and then it will stay on all the time. LED light, I can turn the light on high or low or SOS remotely. Powerlifting. It says suitable for powering up to 1200 watt maximum heating devices on a pure resistive load. It reminds you, it says do not power a refrigerator or an air conditioner, but you can turn up the power for a resistive load, in other words, an incandescent lamp or a heating unit, up to 1200 watts. The rated power still remains 600. That's just to give you a little extra boost for it. What will happen is, I guess, probably the voltage will drop. If you turn that on, it will turn on that feature to give you more power. We'll turn that off. And this working mode, if I tap standard up here, okay, standard, turbo, or silent, and this will turn up the turn up the charging on here, and it says they only recommend turning it up to turbo when you really need to charge it up quickly. It'll crank up the power that it charges. Of course, that could reduce the battery life going to turbo. So normally you've got silent, turbo, and standard. Oops. Silent will slow down the fan to reduce noise. Firmware upgrade. Let's see if there's an upgrade available. Current version and the latest version. So it looks like there are a couple of updates, so let's just download these updates, and this will apply the update to the device. I'll click start. Okay, we're going to just let the mobile device sit here for a few minutes. We've got an indicator on the display to indicate that it's updating. And we will put the most current software on the unit itself. Now my firmware is current. I'm going to upgrade the DSP as well. So same thing, I'm going to get the same warning. It's going to shut off while it's upgrading the DSP. And now we get an indicator on the other side indicating that the DSP is upgrading. And I should reconnect again. And if I go to the settings here, you see, now it's telling me I'm at 90%. Was I higher than that before? I don't remember. Anyway, it's still charging at 151 watts, but it'll tell me that my firmware is current. There's no new version available for it. So we're updated. I've got eco turned off because if I put this thing into service, I don't want it shutting down after a few hours, but that would normally be something you could turn on and off. So what the eco mode does is, after 4 hours, if you're using less than 10 watts on the AC inverter or 1 watt on the DC output, it will shut off to save power. That's all that does. So eco mode could be left on if you were using this as a UPS to power a computer, for example. Computer is going to be drawing more than 10 watts, so it won't shut down. But if you were running something of very low power, like some LED lights that are drawing less than 10 watts, and you didn't want them to shut off after 4 hours, you could turn the eco mode off, and then the unit will stay running until the battery is depleted. Anyway, that's the basic rundown. We've had a look inside. Looks to be pretty well built. Put a link in the description. Thanks for watching. We'll catch you in the next one. Bye.